Hello and welcome back to a series of lectures on the herbal medicine. We have so far discussed many important plants, how one can conserve them and commercialize their production. Today we will be talking about another important plant, that is Atropa acuminata, commonly known as Indian belladonna. This plant is actually a replacement or a substitute for Atropa belladonna, where the potential is at par in terms of not only the part that we use, but also what the potential of these parts is. Ordinarily, this plant was about 20 years back a very common plant distributed in high altitudes, especially in the Kashmir and other temperate Himalayan regions. But at present, because of the overexploitation as well as habitat destruction, this plant is rated as critically endangered, and that in turn necessitates the methods which can be useful not only in conserving it, but also commercializing the production, so that that production is fulfilling the demands that are increasing with every passing year. This plant is popularly known as Sagangar in Hindi, Yabraj in Bengali, Suchi in Sanskrit, and Lufar in Persian and Unani. And in literature, there is a mention of these names in terms of a remedial measure for different ailments, which reflect that right from the time this plant was discovered, its use has become common among those who were aware of its potential. This plant is at present seen distributed at high altitudes, but in those altitudes the density as well as diversity of the plant is limited. As you can see that in the figure A, the number of plants per population is limited, where only a few, about 5-6 plants are seen per population, which reflect that there is an uncontrolled extraction of this plant from the natural habitats, which is in turn decreasing the density as well as the diversity of the populations. In these natural habitats, normally once the plant reaches its flowering phase, we find that the number of flowers per plant is much lower than we ordinarily expect, as you can see again in the fig 2, wherein in an inflorescence only a limited number of flowers are seen, even though once the flowers attain maturity, they are also ornamentally beautiful, which is actually also seen as an attracting feature, wherein insects, birds are attracted towards the plant, and they in turn try to destroy not only the inflorescence but also sometimes even consume the fruits, which you can see in the D figure, wherein the mature fruits of black color are seen, and these fruits, if consumed by animals, are in turn resulting in destruction of thousands of seeds, which may ordinarily produce thousands of seedlings, which in turn can produce healthy plants for the commercial usage. However, in natural habitats, we ordinarily find limited seedlings developing, that is in turn reflecting that the birds and animals try to consume fruits, and only a few seeds drop and give rise to the seedlings, which in turn develop into a mature plant and is in the next growing season harvested for the commercial extraction. Ordinarily, if we look at the literature, many different uses have been attributed towards the Atropa, but normally the use of the root as well as the leaves is common, where at the end of the growing season both root as well as the foliage is harvested, and they are used as number 1 as an anodyne, number 2 as a diuretic, number 3 as a mydriatic, number 4 as a narcotic, and more importantly as a sedative. However, here important feature is that the consumption for sedation purposes, if in higher doses than that is recommended, sometimes can in turn cause narcotic effects, wherein the practitioners recommend that only a limited quantity of the sedative should be consumed to overcome the pains and other ailments. The other important uses that have been reflected in different literatures is that the leaf and root extract is used to dilate the pupils, wherein the doctors use the dilation to actually operate upon the patients where the eye surgery is important. However, again here the quantity of the root and leaf extract is used in smaller doses, because high dosage is seen to affect the vision also. Sometimes it has also been used as an analgesic, as an antidote, as an antispasmodic, as a diuretic, as an hallucinogenic, as a mydriatic, as a narcotic, and as a sedative. However, in all these uses, the recommendations is that not only should one harvest the part that he uses, that is the leaf or the rhizome, at the proper stage of the life cycle of the plant, but also try to use the recommended dosages so that excessive consumption does not in any way affect the part for which it is used or the consumer, so that the consumption does not in turn reflect in its negative effects on the consumer's health or the part of the body for which it is used. The modern uses, that is wherein the chemical analysis of the plant has been taken into account, has in turn reflected that the root, if consumed in larger quantities, can sometimes act as a poison. These in turn reflect that whatever active component is lying in the roots, if the concentration of that is at its peak, if consumed at that stage, can in turn affect the consumer and sometimes may result in the destruction of the part for which it is used, or sometimes even kill the patient as a whole. That is in turn reflecting that chemical analysis of the part that we use is also essential. Another important property of the plant that has been analyzed is that if it is harvested and fed to animals, that animals sometimes can actually have a negative effect on whatever component of that animal is consumed. For example, if it is consumed by cow, it has been seen to negatively affect the quality and quantity of the milk that is extracted from these. Or if consumed by the sheep, the quality as well as the quantity of the meat produced by those sheep has also been seen affected negatively. That in turn reflects that the consumption of these without actually being assessed is in turn proving harmful to the animals also. The harmful effect of these parts has been seen to be mainly because of the high toxin concentration, wherein the most important components are number 1, atropine, number 2, scopolamine, number 3, hyoscyamin, and number 4, donatol. These 4 alkaloids, if extracted properly and consumed in proper dosages, have been seen to play a positive role in overcoming ailments. However, if extraction is proper but the consumption is in heavier doses, that consumption can in turn cause destruction of all those who try to consume it without the proper recommendation. Now, once we look at its distribution pattern in the Kashmir Himalayas as well as the adjoining areas, it has been seen that the herb has a preference at the high altitudes of the Himalayas, where it tries to adapt to those habitats where the water flowing streams or glaciers are in the vicinity, and on the basis of this, in Kashmir it has been seen to be growing in the forest in the vicinity of Sindh, in the vicinity of Jhelum, in the vicinity of Chenab, as well as the leather valleys. And in all these areas, each population is reflecting a similarity in its habitat as well as the density, dependent upon what sort of competition it is facing from the adjoining areas or what sort of competition it has to face from the other species growing in the vicinity or in the same habitat in which these species are growing. It has been seen that if it is growing independently, not only the number of plants is high, but the growth of the plants also is more dominant. Yet, if it is growing in the vicinity of other plants, wherein it has to compete for space, it has been seen that not only the height of the plant is getting affected negatively, but also its productive quality is getting hampered. Now, as you can visualize, we have seen that as soon as the sprouting begins in the first figure, the number of plants that sprout is limited. That in turn reflects that lesser the number, the speed of the growth may be superior. However, if the number of plants in the same population is denser, in that case the speed of growth is slightly slower. That is again reflecting that the competition is in turn affecting the developmental features of the plant. In the figure second, you can see that in the natural habitats, the flowers per inflorescence is much higher that is reflecting that lesser the number of plants, higher will be the inflorescence production, but higher the number of the plants, lesser will be the inflorescence potential. That again shows that in the habitats, the lesser the competition, denser the populations, the higher the competition, lesser the number of the plants per population will be. As again you can see in the fig C, that you see since the plant number is lesser, the plant itself is showing tremendous growth. But in the next population, since the plant number is high, that is the D figure, the plant itself is also showing a less density of the branch as well as the lesser number of the flowers. That again reflects that higher the competition, lower will be the potential of the plant, lesser the competition, higher is the potential of the plant to produce whatever we have to harvest for the consumption purposes or for the extraction of the active components. Now, in Kashmir Himalayas, once we assess its habitats, it has been seen that on an average, the plant shows a height of about 185 centimeters. Now, that again is dependent upon what sort of habitat it is growing. Now, if it is growing in the vicinity of the aquatic streams or glaciers, there the plants are taller. But if it is growing away from the aquatic habitats, in those conditions, not only the height is lower, but also the density of the branches as well as the foliage is much lower than the other plants. That in turn reflects the aquatic habitat vicinity is also important in the plant, so that not only it is surviving, but also producing whatever is commercially useful, that is foliage as well as the rhizomatous portion. Now, once we look at the plant in natural habitats, there ordinarily we find that every year there is a natural development of each population. Then once we assess what is the propagation means, in that case two methods have been analyzed, and both methods have been seen to actually have a potential not only in natural habitats, that is in situ conditions, but also in the ex situ conditions, that is where one tries to commercialize their production. These methods are A, vegetative means of propagation, that is wherein any vegetative part can be used to multiply it, and that part in turn can produce whatever we need. Now, in case of this plant, that is Atropa acuminata, we have seen that its underground rhizome is the main part that can be used for multiplication, and that multiplication in turn can help us to commercialize its cultivation. Now, ordinarily this rhizome is harvested in the early months of the spring, that is in the March, April or May, and in these months we try to analyze which part of the rhizome has a larger number of vegetative buds on it. Higher the number of buds, the higher the number of the cuttings can be raised. Lower the number of buds, lower the number of the cuttings can be raised. Now, that ordinarily means that if we have a rhizome with say 10, 12 vegetative buds, we can split it into 10 or 12 parts. But if the number of vegetative buds is lesser, that is only 2 or 3, in that case only 2 or 3 cuttings can be created, and each cutting in turn can produce a healthy plant in the growing season. Now, this has been seen to actually prove important in using a vegetative part which is not only economically useful, that is medicinally important, but also using the same part for commercially multiplying the important plant. Now, as again you can see that the rhizome has been harvested from the plant, which you can see in the figure A, and this rhizome, as again depicted in this figure 2, is showing multiple portions, and each portion can in turn be split longitudinally, that is wherein we take into account the vegetative buds on the rhizome portion, and each part that we create must have at least 1, even if necessary sometimes 2 buds, and then after splitting sow it under control conditions. Here control conditions are important, that is wherein we can not only assess what the soil is and how we can manipulate that soil, that is how we can provide it whatever the irrigation needs are and whatever fertilizers are required, and how we can regularly assess whether the plant is in need of irrigation or the plant is in need of the fertilizers. Again, you can see that in the fig C, these cuttings in turn show an important potential to give rise to a healthy plant, which actually have been raised from what you can see in the fig D, wherein the small cuttings have been sown and each cutting has given rise to a healthy plant. That means if a rhizome has 10 buds, 10 vegetative buds, these can in turn give rise to 10 healthy plants in one growing season, which ordinarily is seen to produce only one healthy plant. That is, one parental plant produces one progenial plant in the natural habitats, but under controlled habitats, that is under commercial conditions, one can actually convert one rhizome into larger number of rhizomes dependent upon how many vegetative buds it has, and each bud in turn can give rise to a healthy seedling, and which in turn can produce the healthy rhizome for the extraction of the active components for medicinal purposes. Then, if we try to assess how the plant is sexually able to multiply, that is, what is the sexual mode of reproduction in the plant, in this case we have seen that it produces large number of berries per plant, and each berry in turn contains large number of seeds, wherein the number has been seen to vary minimum from 200 to maximum 500 per berry. Now, if one plant is producing 30 berries and one can actually harvest about 6,000 seeds from those, and if these seeds are sown under controlled conditions and monitored till they give rise to a healthy seedling, each seedling can in turn produce healthy rhizome as well as the foliage, which can be used for medicinal purposes. However, in natural habitats, these seeds are shelled on their own, that is, the fruit ruptures and the seeds are dispersed. But if one wants to commercialize the cultivation of this plant, in that case one has to harvest the berry at a stage wherein it has attained maturity. Now, this in turn shows that the harvesting should be regularly assessed, wherein we are able to actually harvest berry at a mature stage and allow it to dry under normal conditions. After it is completely dry, try to manually rupture these berries and then see what is the health of the seedlings, that is, are they actually showing proper growth, is their size normal, and manually checking them, are they showing the normal density in the interior of the seed. That will reflect whether the seed has been harvested at a proper stage and whether these seeds can be sown to give rise to a healthy seedling. Now, again, in this case, one sees that in natural habitats, these seeds are shed in the month of September or October, and that in turn exposes these seeds to severe winter. That obviously shows that the potential of the seeds is to actually sustain what the severity of the winter is, wherein temperature may drop as low as -20 degrees also. However, if we want to cultivate these under controlled conditions in those areas, one has to, after harvesting, subject these seeds to different treatments, wherein we can use physical treatments or sometimes even use the chemical treatments. However, the method of these treatments should be on the basis of what the size of the seed is and what are the control conditions under which we can actually subject these seeds to these physical and chemical treatments. However, it has been seen that one must assess that at which stage one can subject the seeds to these treatments. Ordinarily, in natural habitats, it has to directly face whatever severity of the winter or other competition it has to face. But under controlled conditions, after harvesting, we can actually manipulate the treatments also. That is, we can harvest the seeds, store them under controlled conditions, and when the need arises, subject them to different treatments, and each treatment we can also manage. That is, if we give it a treatment with a chemical, we can actually be able to manage the concentration of that chemical, or if we subject it to chilling treatment, we can also manage the duration of the chilling treatment, so that that will not in any way negatively affect the seed or its potential to give rise to a healthy seedling. Ordinarily, these in turn are giving rise to important seedlings. However, question is, can we ordinarily transplant these seedlings to any habitat, or we have also to assess in which habitat we can grow these seedlings. In natural conditions, this habitat is suitable for the seedlings because they fall in the same habitat in which the parental plant is growing. But under controlled conditions, we have to again assess what the requirement of the plant is. That obviously means we have to see not only what soil we use, but also what is the pattern of irrigation as well as the supplementary treatment of the nutrients in that soil that is essential to give rise to healthy seedlings. That obviously means we have to develop what we at present refer to as an agrotechnology. That is not only domesticating the plant, but also trying to commercialize the cultivation of the plants in different habitats, so that one can be able to assess which habitat is more suitable in comparison to the natural habitat, wherein only one type of the soil or one climatic condition or one type of the competition is to be faced by the plant. Under control conditions, one can not only make the soil of our choice, but also provide it the controlled irrigation pattern as well as the controlled fertility, that is add nutrients at specific intervals, and also manage to assess what the positive or negative effect of these treatments on the plant are. Now, for this there are two major requirements. One, either to have an open field in which we can subject it to different treatments, or have controlled conditions, that is either a pot or a polyhouse in which we can maintain whatever physical or whatever chemical treatment we have given to these plants. Now, ordinarily pots are considered to be more suitable habitats in which we can carry out controlled cultivation, because it is easy to shift each pot manually to whatever habitat we want. But if we grow it in a field, in that field it is difficult to maintain whatever irrigation pattern or whatever temperature or other fertility of the soil is essential. That is why we have seen that pot cultivation under controlled conditions is more suitable than the open field conditions. However, in both cases one must try to see which nutrient is more suitable in comparison to the others. And as you can see in the figure, we have used different sets of pots, and in each set we have tried to actually use different soil types, and in each soil we have tried to use different chemical as well as organic nutrients to assess which particular treatment and which particular type of the soil is more suitable not only for the plant to survive, but also to produce whatever quality product we actually want to commercially produce. Now, as you can see in figure, we have shown different types of the soils, and in the fig B we have depicted that in some we use NPK, in some we use NP, in some we use only N. That obviously means we have tried to give it 3 different treatments and assess on the basis of these treatments what the potential of the plant is, not only to sustain these treatments, but also to produce what the healthy rhizomatous portion or the foliage is. In the fig C, you can see again we have tried to compare 2 different NPK treatments, and again in one you find that the plant size is larger, and in the second plant size is smaller. In fig D, again you can see we have shown 2 plants. Again there is variability in the size of plant, as you can again see in the fig E. Now, here this variability is actually showing that the habitat is in turn affecting the plant size. The taller plants have been grown under the shady conditions, the dwarfer plant under sunny conditions. That in turn reflects that if we want to improve the number as well as the density of the foliage, in that case shady conditions are suitable. But if we want to increase the size of the rhizome, in those cases it has been seen that the sunny conditions are more suitable. Whatever dwarfer plant we have, those dwarfer plants are actually allocating major resources towards rhizomatous portion, reflecting that the sunny conditions are suitable for rhizomatous portion, while as the shady conditions are suitable for the foliage portion. That in turn reflects that if we want to harvest foliage as a commercial product, in those cases we have to grow them in shady conditions, while as if we want to use rhizome as the major or main commercial part, in that case we have to grow it under sunny conditions, and that will in turn produce the superior quantity of the rhizomes, and that rhizome in turn would be commercially useful. Now, once again, if we want to now commercialize its cultivation in the beds, that is after assessing the means of propagation, that is where we use rhizome or the seeds, in that case can we subject this to different treatments, or can we actually be able to manipulate what we refer to as in vivo propagation, that is manipulation of propagation under controlled conditions, that will also be able to show that we will be able to modify that. As you can see again here, we have tried to see in the controlled conditions the rhizomatous portion is grown in the open fields. Here we find that the fig A shows that the rhizome size is much larger, while as the fig B shows rhizome size is smaller. But these rhizome size variations are in turn related to actually regeneration of these in vitro propagules under two different habitats, which reflects that habitat is also responsible for the improvement in not only quality but also the quantity of the product. Now, on the basis of this, we can show that if we are able to develop proper strategies through seed based or through vegetative means for multiplication as well as commercialization, one can easily be able to produce what are the important commercial products, as is seen in fig A, B, C, D and E, wherein different densities as well as different types of the plants are shown, which reflect that how much of the potential of the plant is controllable or manageable under ex situ conditions, so that this plant, which is critically endangered, can not only be conserved but also commercialized in suitable habitats. That reflects that this domesticated plant, that is a plant that has been grown under controlled conditions, can be at par in terms of its quality as well as quantity with the plants that are growing in the natural habitats. Now, those of you who want to commercialize the cultivation of Atropa acuminata should follow these guidelines properly and in turn develop a suitable protocol for first its conservation and subsequently for its commercialization. Thank you.